These are the 10 days alone.
Hey guys and gals, I'm here just a sec. Of course, when I played the music, it went right to a commercial. That's amazing. So, just rewind here a little bit. All right, there we go. All right, let's go, guys and gals. Thank you for understanding. Appreciate you being here. Appreciate you being here. Let's go. Check the stream quickly. And then I'm going to shout you guys up. Out. Oh, goodness gracious. Is it late? Must be. Shout you guys out and pump you up. Get you all pumped up and excited to learn math. And I'm going to shout you guys up. All right. Out. Good. Cursor gluing to the slider bar again. Weird. All right, guys, gals, appreciate you hitting that play button. Turn it up. Let's go. Every single one of you awesome. Every single one of you awesome's awesome. Appreciate the last viewers that showed up and was watching the last live stream. Let's go. Let's go. You know I love that. That's super awesome of you to drop by. You guys watching the videos, even if it's not live, you guys are all amazing too, okay? You guys, every single one of you, amazing. This is for you, homeschooling parents that are homeschooling their child or children's. I understand why, fully support you in your decision. I'm assuming you have lots on your plate, lots to do. Here to help. Hopefully I could help you. Help your child grow in mathematics. Oh yeah, I love math. I truly do. I'm gonna push out and grind more videos for you guys and gals. There's lots to do. I have lots of ideas, lots of things I can go over and do. if you have any suggestions or ideas yourself, maybe there's a particular area of mathematics you might be struggling with, it's okay. Here to help, guys, gals, here to help. Students, if you're also looking for additional support on YouTube, glad to have you. So with that said, let's get going. Have some coffee, and then flick that old switch in our brain molecules. I know, I just love saying that. It's funny. And yeah, let's get ready to do some math. All right, guys and gals, let's go. All right, we're going to keep moving forward here. Keep moving forward. Okay, everything's good there. All right. Okay. Quickly, let's finish up this, continuing from last video, and then we'll do some, I don't know, some other stuff here real quick, and we're trying to get the wheels rolling and moving a little bit faster here. I feel like I'm a little bit behind because I kind of went over stuff I think I might have already gone over with you guys and gals. I apologize. But let's get on to some new stuff, some new material. We're talking about ratio and rate. Ratio. There's numerous ways to write a ratio. Like 1/2 could be written like that. That's a ratio. Guys and gals. Or it could be written like this. Okay? Ratios, fractions, ratios, all the same. Rate. You hear the word rate? Well, just think like speed, velocity, miles per hour, kilometers per hour, right? That's the most common rate. Heart rate, I guess, is another. Let's see, 5 vowels to 26 letters. That seems like a ratio to me. So 5 vowels. And I'm not going to write everything out, but we'll just write vowels because it's only a few characters. Ooh, wild. Per, obviously there's 26 total, right? 26, well, I guess letters isn't very long of a word either. Okay, so we have a ratio, which is 5/26, or 5/26, right? We can't lower it anymore or reduce it. That's it. What's the percentage? Well, check out my Unit 3. I believe it's Unit 3. Unit 3, Unit 4, go over percentages. There's other fraction stuff there too, guys and gals. Again, don't let fractions scare you. It's just a number over a line over another number. That's all it is. Just gotta separate in your mind as two different identities or two different numerical values, however you want to look at it. Okay, I go over a lot of I work with fractions a lot, give you guys and gals a lot of different examples, a lot of tips and tricks, shortcuts, you name it, to help you do well and succeed in mathematics. Let's simplify it and make it easy, because it really truly is. We're doing like basic level stuff here, guys. Okay, basic level stuff. That's okay. That doesn't mean you're silly or anything. You're just learning and growing. Everybody has to start somewhere. All right, 110 characters texted in 2 minutes. Woo! That's a lot of thumb typing, huh? I'm at about 1,000 or 10. No. Yeah. No. Sorry, I got that wrong, guys. I got it wrong. Got my ratio backwards. I'm at about 2 No, I don't know. Let's see. How many can I do in a minute? I probably could do 25 in a minute. Characters. Somebody's typing 110 characters, texted in 2 minutes. Okay, that's a rate, right? They're typing 110 characters. That's a time frame, right? They're typing 110 characters in 2 minutes. Okay, we could turn that into a rate easily. Okay, we can figure it out. It's obvious if we know to get half, you divide it by 2, right? It's no different than multiplying something by 1/2, right? You're still dividing. You know, I could go 110 here, right? However you want to look at it. We're multiplying by 1/2, or we're just dividing by 2. It's the exact same thing, right? So they're grinding out 55 per minute, right? Some people could do a lot more than that, I'm pretty sure. Pretty decent. Other things you may see, scaling. I call this part of scaling. It kind of reminds me of my drafting a bit. I'm going to kind of try to draw a rectangle. Okay, it's not going to be perfect, guys and gals. Okay. Alright, so let's say this was a certain distance. Ugh, terrible, terrible. Okay. Same thing with here. Okay, you can actually measure this. So let's say it's a map or something. I don't know. Or maybe you're physically measuring something. I don't know. Just doing some random examples. And they have a scale. They say 1 centimeter. We'll just pretend it's a map. I don't know. Whatever, right? And you're traveling some highways. There's some roadways. They're all connected. Right? Blah, blah, blah. You know. Terrible drawing, but you get the idea. So it's a map, and they say 1 centimeter represents 2,500 kilometers. So what they mean is if you take your ruler measuring instrument and you measure like 1 centimeter, I'm just going to exaggerate it. You measure that distance, right? Okay, for example, say you measured that. Okay, and let's say that was, I don't know, 1, 2, 3, 4, 5, I don't know, 7, 8 centimeters or something, just random. You got 8 centimeters you measured. This is where you could actually use, this would be your ratio, 1/2500, right? And then I could turn it into what would the distance be, right? So I measured 8 centimeters. You just got to make it match. This is the measured value. This is the measured value. So that's our numerator. So I'm going to have 8 here, and this is going to be our unknown. I'm just going to use D for distance. Essentially, it's going to work out to 8 times 2,500. Okay, that would be our distance in kilometers. And that's kind of where you could use ratio proportion as an example. Okay, guys? Again, if you have a map, you'll see a scale on there. And let's say you're traveling and such. And hopefully you brought a ruler. You can measure the distance. You just need to estimate it. It doesn't have to be perfect. And then you could go, well, okay, we got, I don't know, 20,000 kilometers to travel. That sounds crazy, but let's just say, I don't know, 1,500 kilometers to travel. More reasonable. Or even 2,500, whatever. You can measure the distance and then you can kind of figure out how long it's going to take you, right? With breaks and such. All right, let's move forward. A computer problem. Here we go. Here's something we can kind of work on. I want to kind of get rid of this now because we're done with that. Okay, we have your local utility company. They charge, I'll just write it in dollar value, but they charge 22 cents. Okay, for 2 kilowatt hours. So I'm just going to write it as K watt hours. Okay, we could actually, I think we could still use it, but normally you would want this to be a value of 1 instead of 2. So for equivalency, it would be essentially 11 cents for 1 kilowatt hour. Right, they're equivalent. Right, guys, gals? Maybe I'll write 4 here so it doesn't look so... Okay. All right, good enough. Okay, so a desktop computer, so you have a computer. You can draw a visual if you want, if it helps. Nothing wrong with drawing visuals. Right? And so that's the monitor computer. So a desktop computer and monitor are left, they leave it on. It's literally running all the time, which isn't really that good for it. So they're saying it's running, it's using 1,300 kilowatt hours. Okay, for an entire year. So that's for 1 year. Okay, that's wild. I don't want to get into talking about computers. I mean, if you buy, I don't know, I call them potato PCs. Lots of them out there, and they're just thrown together cheap builds, overpriced with garbage components, and they're sold for a high dollar. Those ones I don't care about if they're running all the time. They're just throwaway PCs. People are making good money on it because it's just junk. I design PCs, so I know what. Anyways, not trying to get on a sidetrack here. I'm actually doing videos using the PC I built 2 years ago. I have it on Discord. Dated when I built it. Anyways, still grinding, still going. Better knock on wood, because I don't want karma to kick me in the old hee-haw. All right, back on track. Anyways, if you build a custom PC, leaving it running for a year, no bueno. Okay. Another tip: don't have your PC sitting on the floor if you have a carpet and animals. It's just a vacuum cleaner. Okay, that's another tip. If you do that, you pretty much turn your PC into a floor vacuum. Always keep it off the ground. Especially if you dump $3,000 or $4,000 into it, you're going to want to do that. Again, that's not really much of a sidetrack. Just some advice, good advice and tips. Okay, that's positive for anybody. What is the electricity cost to run the computer? Okay, so I could use the 22 I could, but I think I'm just going to use this. Because really it's the same thing. I don't know why you would want to do that, but that's okay. So how do we want to do this? I guess we'll do value on top of hours. So 0.11 per 1 equals, we don't know how much it is, so this is going to be C for cost, and I guess 1,300. Maybe I should be using 2, I don't know. It probably doesn't really matter, but C equals, your setup is key, okay? Money value over top of, this is your kilowatt. Money value over top of your kilowatt. I'm comparing this with this, okay? That's what I'm doing. So we have 1 times C is obviously C. I don't need to write the 1. It's imaginary, guys. You don't need to write it. And it's going to be 1,300 multiplied by 0.11. Okay? I guess I could do the long multiplication, but we'll just do it on a calculator. Times 0.11. And that turns out to be, that's actually pretty cheap. It sounds like a monthly thing, to be honest. It's not really using a lot, but $143 for the year, essentially. Now, do I have answers for that? No, that's an example. It doesn't give me any answers. That's okay. Hopefully I did that right, but it makes sense, right? That's how much for 1 kilowatt. It used 1,300 kilowatts. You just straight multiply it. So I'm going to call that a win. Let's keep going. Serious mode, guys and gals. Let's learn. Okay. If you earn $150 in 12 hours, okay. Now, normally regular hours is 8. I don't know for you guys what it is. Anything extra is overtime, but I don't think they're using this, so I don't know. But here, I'll show you what I'm talking about. So $150, that's what they made. Okay, and they're making them work 12 hours, so that's $150. They work 12 hours. If we're ignoring all this, like, because we would have to break it into parts to do it, the question doesn't really say that. It doesn't talk about overtime or anything. So, I don't know, you could only assume it's all regular hours. Slave driver company. If I had employees, I would never do that to them. So they made $150 in 12 hours. For 12 hours. How much will they earn if they worked 40 hours? So we have our ratio here kind of already. So I guess it doesn't really matter how you set it up. It doesn't matter if money's on top and hours is on the bottom, or hours is on top and money's on the bottom. It doesn't matter. What does matter is your ratio set up. Okay? The left side has to equal the right side. Okay, so it says 40 hours. So if you earn 150 in 12 hours, how much will you earn in 40? Okay, so this is the hours, right? So you have to be consistent. Your setup, your ratio proportion setup has to be exactly the same. So this is the 40. And this is the unknown. So how much? I don't know. I'm just going to use D for dinero. Whatever. It doesn't matter what variable you use. I could use elephant. It doesn't matter. Okay, so same thing. Ratio proportion, cross multiply. It's all the same, guys and gals. So it's going to be 12 times D. You normally write the value, the numerical value, then the variable, and you make that equal. Here's the inline part. I have to sneeze, guys and gals. Bear with me. Okay. Whew. Are we good here? Okay. Just check the stream quickly. Sometimes I get these sneezes, they just come out of nowhere. Okay. Whew. All right, we're good. Awesome awesome. Appreciate you being here, watching and learning. Every single one of you. 120 IQ and higher club. Beautiful, awesome, intelligent people. Appreciate you watching and learning and growing. You guys are awesome. Okay, 12 times D and then equals 150 times 40. It doesn't matter if I go 40 times 150. We're just still multiplying two values together. Okay? All right. So here we go. This is the setup, right? Your setup, then you do your cross multiplication. Left side equals right side. Left hand side equals right hand side. That's step one. Step two. I should write these in different spots, but excuse me. Cross multiply, step one, step two, left hand side equals right hand side, again in a linear fashion or in the same row, right? Everything's horizontal. Okay, so now we have to isolate D. So 3 is isolate variable, which would make more sense. Isolate variable. And we can just call it isolate. Isolate var. Okay? Short for variable. Okay, isolate var. And if you've been following, you know how the steps go with isolating. So we end up with D. This is the isolate part. This is still our numerator, guys and gals. Okay? Which is 40 times 150. I'm just going row by row here and showing you. Here's the 12 right here. Okay? So we can reduce here. We can. Let's see. We can't really cancel the zeros here because they have to be numerator, denominator. So let's see. 12. Well, 2. We know we could split this in half. But I think maybe we'll go with reducing this. You're going to have to reduce anyways, so I think we'll just reduce this here. So 2 goes into that. 4 goes into that. Yes. Does 6 go into 40? No. Right? 40. We have 8 and 5. 8 and 5. But 8 and 5 doesn't really go into 12. So I'm just wondering, is 4 our biggest meat off the bone? It might be. 12. There's 12 here. There's 12 here. We know 3 goes into 12. We know 6 and 2 is 12. We got to think of a common number, right? So don't let it stress you out too much, guys and gals. All right. If you don't find that the largest factorable number, it's okay. You could just do another factoring step. Okay. So I'm going to use 4. So let's do that. So I'm going to factor 4. We're working with this number and this number. Okay, the 150 is just hanging out for now. We're just ignoring it for now. So 4 is our meat off the bone number. 4 goes into 40 10 times, right? And 4 goes into 12 3 times. So we're left with, okay, don't forget the 150. Ooh, 3 goes into, there we go, see? 3 goes into 15. So here's the reducing step. We could reduce a little more yet. So we're left with 10 and 3 and 150. I'm kind of running out of room here, so I'm trying to kind of put everything. Again, these are gone, right? So we're left with 10 and 150 and 3. So I'm just going to leave the 10. Okay, it's going to be our hanging out number. 3 is going to be our meat off the bone number. Okay, so the number that we actually should have used was 12. 12 goes in that, what? Oh no. Right, it didn't work out that way. But we do know 3 goes into 15. So that's okay. We'll factor twice. So let's see, 3 goes into this, what? 50, right? 50 times 3 is 150, right? So what I'm left with is a denominator of 1, which is kind of perfect. So now all we're doing is straight multiplying. Now with numbers that have zeros, if you just ignore the zeros for now, just multiply the 2 first digits. It doesn't matter what position they are, tens, hundreds, thousands, it doesn't matter. Just multiply the first numerical value by the other first numerical value. So we're going 1 times 5, right, which is 5. Anytime you're multiplying, you just bring the zeros in. So we have a 0 here, and we have a 0 here. That means we have 1 0, 2 zeros. So we just add 2 zeros there. Okay, I'm going to put a decimal there because it's actually a numerical value. So D, I'll just put my variable there. D equals $500. Okay, hopefully you followed that okay. I didn't, it's still clear clear as mud. Again, guys and gals, it's fine if you end up reducing twice. Don't worry about it too much. Okay, first we ended up borrowing from these two numbers. Well, not borrowing, but factoring and reducing these two numbers. And because we had a 3 for a denominator, well, I knew that 3 goes into 15, right? I just ignore the zeros. I just look at this number here and I go, oh, 3 goes into 15, right? We know 3 times 5 is 15, right? I just ignore the zeros. That's all I do. Again, 50 times 3 is 150. The 3's cancel, so we're left with 10 times 50. Woo! Yes, let's go. All right, that's kind of working with some word problems. They're only one-line problems, or one-line word problems. You just got to take the sentence and turn it into, logical numbers and calculations. There's ways to figure stuff out, guys. Okay. Here's another one, okay? Solving a rate problem, okay? This is what we're doing. So, let's say you like salami, okay? I know not everybody's a meat eater, but I'm just going to use this as an example, all right? So we have salami. I'm just going to go, I don't know. No, I'm going to go like this, okay? I'm going to not be lazy and write it out. I'm trying to avoid writing because my mouse writing skills aren't the best, but I'm trying. So you're at the deli and they're charging you $1.59 per 100 grams. Okay? That's kind of common. Okay? So essentially that's going to be that's that a per 100 grams ratio rate. Mind-boggling, but that's okay. All we need to know is for every 100 grams of salami, it's going to cost you $1.59. Essentially, that's what it is. So let's say you say, hello, Mr. Mrs. Deli person, can I have 350 grams? Okay, that's how much you want. Okay, what's it going to cost you, right? So you're set up again, it's all the same. I'm going to put the money value on top. That's per 100. Left side equals. I usually put the ratio that's given to me on the left. And we got to be consistent, right? So figure it out, okay? So this is money on top. This is grams on the bottom. Okay, so this is what I want. Our price is unknown. So that means our 350 is going to be our denominator. Okay? So I'm just going to use S for salami. Good enough. Okay, all the same thing, guys and gals. Ratio proportion, cross multiply. Just be consistent. It's once you get the idea, this is what I say to my son. Once you get the general grasp of it, it's all the same. It's really repetition. You keep doing kind of the same thing over and over and over again. And yeah, it may get a little monotonous in that, but you're going to be so good at it after grinding out a whole bunch of problems. Okay? Again, if you get it quick in the beginning, I mean, it doesn't hurt to do some more practice. Just to, for practice, and why not? But if you got it down, that's great. Okay, again, what the point is, once you get it, you can solve any problem. Okay? Alright, so there we go. We've got our setup. So now I'm just gonna, I can't really reduce, right? We have a decimal value here, the decimals here. They don't work together nicely, so we'll just do the multiplication and just kind of reduce as we're going through the problem. Okay? My variable is here. I like it on the left side, so I'm going to go 100 times S. And I'm going to say left-hand side equals right-hand side, which is going to be 1.59. I'm going to use the brackets because I have a decimal. That's what I prefer. And then there we go. Left-hand side equals right-hand side. Same thing, isolate S. So we're going to be, this is what we're going to be doing. So guys, gals, I hope you're following the series. I'm kind of not showing the full steps in hopes that you already have an idea what I'm doing here for the steps. Okay? Appreciate if you just kind of go back, watch from the beginning of this unit, and you'll be kind of with par with us, all right? So here we go, 100. So now we have a fraction we could actually reduce. Let's see. Actually, I could actually move the decimal 2 jumps, to be honest. If you watch my unit 3, hopefully you have. I believe it's unit 3. I teach you guys how to do decimal jumps just to kind of make decimals really simple and easy to understand. When you have 2 zeros, you have 2 decimal jumps. And I believe, I mean, I could do the full math and work it out, but I can factor 100 right out of this. I think the easiest way for me to do this is to just kind of cancel these zeros and then just do 2 decimal jumps. And I believe what I'm going to end up with is 1.59. I'm going to double check my work times 3.5. Now you guys might be wondering, what did you just do? Well, if you practice grinding math numbers enough, you know the shortcuts, and you just get used to how, like I said, guys, gals, the patterns and the sequences and the repetition of numbers. You just learn these things. So I'm going to do the long work. I turned this 100 into a 1, and all I did was just do 2 decimal jumps up here is what I did. Okay? Essentially, that's what it works out to. Okay? But let's double check. Hopefully I'm correct. So now my denominator is 1, which is what I want. That's perfect. I should get S equals $1.59 times 3.5. And I'm going to put it in money value. 5 decimal. I have to round up. So 5, 7. Okay, I'm going to throw in the yays. Now, if you're not sure if that worked out or not, right, you could do the full calculation. I could go 1.59 times 350 and then I'll hit enter, and then I'll divide that by 100. See, when you're dividing numbers by 100, I think of it like percentages. You're really just moving the decimal place. That's what you're doing. Okay, so I just to show you, so you can see, I'm going to do this right here. So you can see, I get 556.5. All divided by 100. Can you see? I rounded this up. The 7 is the round up. So look, whenever you divide by 100, it could be divided by 10,000. It doesn't matter. So here's what you need to understand. If you have 4 zeros, then you're doing 4 decimal jumps. If you have 3 zeros, you're doing 3 decimal jumps. Again, we have 2 zeros and 100. Therefore, we're doing 2 decimal jumps. That's kind of how it works when you're dividing by, numbers that just end in zeros. Okay, if it's just 10, then we're only doing 1 decimal jump. Decimal hopscotch, I call it. Check out my unit 3. I still have unit 2. Next unit's going to be unit 2, guys. Unit 3, I've done geometry. After I get done unit 2, stay tuned. Just to give you a heads up, we're going to eventually be getting into radicals. Don't let that scare you, because they're rad. That's right, they're rad. Measures of area, unit 3. I believe I get into decimal, talking about decimal hopscotch. Same thing with unit 4. I mean, both units I'm sure have that, so check it out if you haven't. Alrighty, again, I put in the time, guys. I'm helping you guys. I'm helping the world. To me, this is doing something positive. There's too much negativity in life. Okay? This doing math is going to take your mind off all the, stuff that's happening, right? We're not going to get into that, though. Because math is fun. How are we doing for time? Let me check the time here. Okay, we're getting there again. I'm trying to keep the videos around an hour. Okay, I could speed this up a little bit too, but again, I like to kind of explain each step and such, so you guys and gals can understand and learn, right? I don't want to really kind of just skip steps. I want you to fully understand what's happening in between, right? Let's see. Here's kind of a good one. So, a lot of times if you're grocery shopping, you'll see those bulk stations. You could buy bulk mixed nuts, or bulk peanuts, or bulk sunflower seeds, or bulk banana chips, or whatever it is, right? So a store charges $6. I'm gonna try to do this one kind of quickly, okay? For 100, so it's trail nut mixture. I'm just gonna, it doesn't even matter what it is. It's all the same for any type of product. The steps are the same. So $6 per 150 grams, okay? How much trail mix can you purchase with $20? So let's say you have $20, right? This is kind of where you estimate it in your head. Now, I don't know if you have taxes. You probably do. I don't know what your tax rate's going to be. I have no idea. But you might want to kind of, let's say you only have $20. You obviously can't go over if you only have $20. So I would just kind of rough estimate it if you're out grocery shopping and you want to know, okay, well, I have $20 and I really want these trail mix nuts. They're so good. Yeah, because I'm going hiking. Let's go. So here's how you do it. Okay, now you gotta kind of think of taxes, so you want to be underneath 20. This would be the easiest way to do it. So you know your times table, right? So $6. We're gonna look at the 6 row. We have $20, but we don't want to go over 20. So 6. If we go 6 times 4, we're over. 6 times 3 is 18. There's our magic number right there. 18. We might be safe with taxes too. I don't know what's 5 divided by 100, stupid taxes, 0.05 times 18, yeah, 0.9 plus 18, yeah, you would be under. So if you have 5% tax, you'll be under $20 still. So here we go. This is what I do. I would go, in my head, I would just, while I'm shopping without a calculator, I would go 6 times 3. That's $18, right? I'm working with this here in my head. Okay, so that's obviously less than 20. That's what I want to be, right? So it's just a matter of one side equals the other side. If I multiply this by 3, therefore I'm going to multiply this by 3. So that means I'm going to get, well, I'll show you the long math if you want me to. That's fine. Okay, we're multiplying. Anything times 0 is 0. Right? 5 times 3, 15. Carry the 1. 3 times 1 is 3. Plus 1 is 4. So we're going to get 450 grams. And you should be fine, because if those 450 grams is going to cost you $18, depends on how much tax you have. So I'm going to get, for $18, I'm going to get 450 grams. Kind of just estimate in your head. That's what I do when I'm shopping, especially if you're on a budget. Okay, and let's say you have 5% tax. Well, 5% tax on 18 is actually 0.9. 9 goes in 18. It's just all decimal. The decimal's moving. That's what's happening. So because it's 5 divided by 100, right? 2 decimal jumps. Anyways, so that's 90 cents. So it's going to be 18 plus the 90 cents. That's your 5% right there. So we're adding. So it's going to cost you $18.90. Now that's based on 5% tax rate, okay? You'll still be, that's still less than 20. Okay, you're going to be fine. Let's go. Hopefully that wasn't too bad for you. I could separate this right here. We have, 1 and 2. I just kind of went a little bit further and did the math, kind of see how much it's going to cost. I mean, you don't really need to do that. This is key right here, is just figuring out, okay, I have $20. I could get 450 grams. You can safely go, no, safely go to the cashier knowing that, you know, you have 450 grams. It should cost you 18 plus tax, right? All right, let's carry on. Do another one here. This is good for you students if you're out shopping. Maybe your parents gave you some money to go eat or whatever. It's good to learn this so you can kind of, it's using your noggin, right? Use your noggin. Think, right? You're a human. Be independent. Learn to think for yourself. Okay? All right. I believe in you. Let's go. The highway rate fuel consumption of a Ford Fiesta is 5 liters. I know there's a lot of metric system going on over here, guys. Again, if you follow units 3 and 4, I teach you guys. I could do the imperial and metric system. Not a problem. Unit 3 and 4, I go over I give you guys a lot of different examples to help you so that, say you only use the imperial system, you'll have an idea how much it is roughly with metric, right? If you're traveling. Okay, lots of tips and tricks I kind of give you guys, all right? Okay, 5 liters of gasoline per. So it uses, this is how much it consumes, consumption. 500, so this would be a rate. So it uses 5 liters for every 100 kilometers it travels, okay, which isn't too bad. Okay, so if you're traveling, and let's say you travel 660 kilometers, you could even go, like if you already know this, a lot of times when you're purchasing a vehicle, they'll give you the city and highway rates. If you know this ahead of time and you know how many kilometers or miles you're traveling, you can kind of get an idea ahead of time. So again, it's the same thing, right? Rate. So I'm just going to go 5 over 100. Left side equals right side. Again, this is ratio proportion we're comparing here. 660. Again, the bottom, the numerator is the kilometers. Okay, you have to be consistent. Okay, don't mess this up. Setup's key. I don't know, I'm going to use G for gasoline. Good enough. Same thing, cross multiply. We're going to get 100 G equals 5 multiplied by 660. Isolate G. G is going to equal to, again, we want G to be a value of 1. Imaginary 1. This is our numerator. Okay, so numerator 660 all divided by 100. Same thing, guys and gals. Right? I'm going to do the exact same thing. I'm going to cancel these 2 zeros, cancel this, and I'm going to put my decimal right there. Okay, again, it's the same thing. All right? Whenever you're dividing a value like 100, for example, you're really just moving the decimal 2 jumps to the left. That's what's happening. Okay, now I have a denominator of 1. So I'm just going to bring this up here. So G is equal to, this is I'm just going to go like that so you can clearly see the zeros are canceled. 5 multiplied by 6.6. G is equal to I guess I could do it. We'll do so. I'm gonna go like this. 6.6. We're multiplying here, so you don't need to line up the decimals. Okay, you have to line up it like that. That's how you do it with multiplying. When you're adding and subtracting, you have to line up the decimals. Okay, that's what you kind of end up with, essentially. 0 times 0 is 0. This is all zeros. Okay, this is all going to be zeros. Place filler, 0. Okay, because we're here now, we need this place filler. 5 times 0 is 0. 5 times 6 is 30. Carry the 3. Same thing. 6 times 5 is 30. Plus 3 is 33. Now, how do you do this with decimals? Now, I haven't gone over a video on doing decimals. I should. Just simply showing you how to multiply decimals. So this is what you do. Okay? Now, again, take note. When you're multiplying decimals, you don't line up the decimals. Okay? Alright? Hopefully I set that up properly. I'm just kind of going off old memory here. And I'll do the math and see if I'm right. So here I have 2 jumps with a decimal. And here I have 1 jump with a decimal. So that is 2. 2 plus 1 is 3. Which means I'm going to do 1. I should actually add it here. But I'll just do that. We have 33,000. I know it sounds like a big number, but I'm moving the decimal 3 jumps. So G should equal to 33. If you guys have any questions on what I did there, just let me know in comments. I'm trying to show you little quick tips and tricks here on the way to do things. Again, you don't line up the decimals with multiplying, okay? I just added these zeros as a place filler here, and then I just started multiplying. 0 times 0, 0 times 0, 0 times 0, right? It's all zeros. Because this is essentially like the next digit over, that's why I added the place filler. 0, that's the place filler. And then I multiply. 0, 0, right? Okay, let's have a look. 6.6 times 5. Let's go. Drop the yays. So I went off old memory on that, guys, gals. I literally did. It's stored in the old memory banks. And it's been a minute since I've been in college. But I loved math so much, I just dove right in. Right? Dove right in. It was kind of like playing a video game, but it was a mathematics video game. I loved it so much, I just dug right in and I did lots and lots and lots and lots and lots. And I'm not bragging or anything, but it was like one of those things where it just clicked for me. And I'm like, wow, I have a brain. I could do this stuff. And as soon as I said that to myself, that's all I wanted to do when I was going through college. I majored in my Stream 1. I had Stream 1 honors in college. Calculus was one of my majors as well. I mean, it's been a minute since I did calculus, but I mean, I wish you could turn back time, honestly. Anyway, so my answer should have ended up being liters. Okay, 33 liters. That's what we end up using. Okay, I'm going to clean that up. I'm going to leave you with kind of your own problem. Again, if there's something that maybe I try to explain things. I don't know if I over-explain, but I kind of explain things so that I make sure that you guys understand. I don't know if it's too much. If you already know and you have a good idea, you can just kind of skip forward, right? That's the great thing about YouTube. You could, if it's not I mean, I guess you could skip when it's live and pause and stuff, but if it's not live, you could just kind of skip ahead. All right, appreciate you being here. You're awesome, awesome. Oh, right. I guess I should finish that. So if our answer was 33, right? 33 liters. If I'm right. If gasoline sells for $1.20 per liter, well, this is just straight mathematics, right? So if 1 liter is $1.20, we could still do our setup and cross multiply in that, but we don't really need to. This is kind of like, for every liter it costs you $1.20. We have 33 liters, so essentially it's just going to be straight multiply, guys and gals. Straight multiply. Again, you could do the same thing here. If I'm right, I think this is the way to set it up. I don't need any place filler zeros. I just want to kind of test this out. 33 times 1.2. I should end up with 39 if I set this up properly. Hopefully I do. 0.60. That's what it's going to cost. Okay? Let's find out. 3 times 2. Yeah. Oh, hang on. Just trying to think of this for a sec. Do I move? Man, it's been a minute since I... Well, when do we do decimals? Isn't that in like elementary? Not middle school, but before middle school? Okay, let's find out. 6 times 3. 6 times 2. 3 times 2 is 6. Same thing. Place filler. 3. 3 again. I feel like it's kind of wrong. Oh, yeah, it's already feeling like it's wrong. Maybe not. We have no decimal jumps. We only have 1 decimal jump. So that means, boom. I actually might have done it. Look at me. Yeah. Because I was thinking, is this the setup? But I was wrong. Okay, in my thinking. It's not like that. Right? Because then I would be adding an extra 0. Yeah, that's wrong. Okay, so I did it right. Going off memory again. And we're multiplying here. Again, the decimal for 33 is right there, right? You can see we don't line up the zeros. We line up the so our last problem we did I don't know. Anyways, you see, I can't rewind it. But that's what you do, okay? And here's my little trick. There is no decimal jump here because the decimal's there, but I do have 1 decimal jump here. So that's how I got the 39. Okay? 39.6. And that's how I figure it out. I only have 1 decimal jump. No decimal jumps here. So essentially it's 0 plus 1. Alright. That's the cost. You could do it on your calculator, guys and gals. You don't have to do I mean, if you want to do practice decimal multiplication, nothing wrong with that. If you want me to do a video on that, I'll kind of try to refresh my memory on that. I'll grind out a bunch of problems just so that you know, I don't mess things up, and we'll do some decimal multiplication. All right, so here we go. Here's the one I'm going to leave you with. Paper. So I don't know, it could be anything. Something weighs a certain value in weight. Okay, we're just going to use paper, whatever. It's 4.9 per, so this is kilograms, right? This is kgs. Pounds, you can think of it as whatever. Pounds as well. Per 500 sheets. Okay, per 500. How much will 700 sheets cost, right? So, or no, weigh, sorry. Weigh. $700 sheets of paper. Okay, it's all the same thing, guys and gals. Do your setup. Okay, do your setup, and then use, I don't know, use W for weight. Your variable could be W. Just use that. And what is the weight? Is that right? Yes. What is the weight? Pretty easy peasy. I'll save this and we'll do that at the beginning of the next video. And yeah, let's go. Appreciate you watching, guys and gals. Parents, homeschooling your children here. Children, here to support, help you, your child learn mathematics. That's kind of the goal. Same thing with students. Maybe you have a fuddy instructor that isn't teaching the subject, which they should be doing, and you're resorting to YouTube for extra support because you actually want to learn and you actually want to pass, right? Which is awesome of you. That makes you pretty epic, to tell you the truth. I'm going to leave it at that. I'll see you guys and gals next video. Johnny Whiskey Tango Sharp, doing a bunch of different stuff over here. But I'll see you guys and gals next video. For now, take care, and peace!